still haven't figured out how to make it record more than an hour at a time. But, oh well. All right.
I have a question.
Yeah.
Okay, for the very bottom one, okay, what is that on the right side? The right side? That you square, circle thing? Yes.
Oh, sorry.
Okay, where did that come from?
What can come out of here? 2x minus 5. And what's left? 3x plus 2. That's grouping, right? The 2x minus 5 can come out. So you're left with 3x plus 2. All right. Oh, so watch. This is kind of nice. Here's one major advantage to this method. Oh, let's see. Let's do this one. That looks freaky. Oh yeah.
What are we doing? Factoring?
Yeah. So what's the thing that you're not used to seeing? I mean, the number shouldn't throw you off that much. It's not that terribly huge, but you're not used to seeing another b and a b squared there, right?
Yeah.
But I mean, really quickly, little side note. Let me give you a quick, really quick, easy problem. Now, x squared makes what and what here? Xx. Y squared makes what and what here at the end?
Y.
Okay, now your whole problem is just make the numbers work. Factors of 3 that make 4.
3 and 1.
1 and 3, yeah. Now, the middle term has an x and a y in it.
Yeah.
Of course it does, because when you multiply these, don't they get 3xy? Plus 1xy makes 4xy, right? Bless you.
Thank you.
So when you have a variable at the end, it really shouldn't bother you. It's exactly as if it wasn't there. You would have plus 3 plus 1, but there's a y squared, y to make a y squared at the end. Here's the good thing about these. I don't have to worry about that at all. The grouping step does it for me.
Isn't it 5a?
What's that? What's the first step on this problem? I like it. 25 times 6. And what's that? Yeah, 150. Now this won't be too bad. What factors of 150 add to be 25?
75.
10 and 15.
10, 15, yeah.
So whenever it ends in 0, I want to try the 10 one first. Because if it works, I'm done, right? So sure enough, 10 times 15, that makes 25. So how do I rewrite this problem? That's still here. Plus 10ab, 11. Cool. And that's still there. So all I did was, that's here, that's there. I rewrote this as this. Don't forget your AB. If you just put plus 10 plus 15, that's no good. That doesn't make 25 AB. I can have your AB on there. And what can I do now? Now you can group. I got 4 terms I can group. Comes out of these two.
5a.
5a.
5a plus 2b.
I like it. 10 divided by 5 is 2. A goes away. I'm left with a B.
Plus 3b.
Good. A 3 comes out.
Plus 2b.
And a B comes out. 15 divided by 3 is 5. B is gone. 3 goes in 6 twice. And 1B is gone. Those are the same, so I can go to the next step. Again, the process didn't change. I multiply these first because the number's in the front, not 1. Factor that to make the middle term, and then I break up the middle term. 4 terms now, grouping. Grouping should be easy. If it isn't, have you done that homework yet? But do it. Focus on it. Obviously, you need it desperately. We need to make that grouping easy. Now what's the last step then, since these are the same?
2b and 5a.
5a plus 3.
I like it. Craziness. And to check it, I would just multiply back out and see if I got that. So if you can't GCF, none of this makes sense. GCF, you got to be able to do. Grouping should be relatively easy then, because it's just a couple of GCFs. And then this step shouldn't be that evil, because it eventually becomes grouping on the second step here, right? Let me give you guys one more, and then we're going to get into the next section. Not the last section.
Oh, we did.
Let's see. Now, if you're still at the stage where you want to add some of these together, you got to come see me. Are there any like terms up here?
No.
Definitely not. The exponents are different. No like terms, right? What's that?
Why did the fourth is the same as all three?
No, they're not.
That's a different question, though. It is the same, so it will be a GCF, but are there any like terms?
No,
Can I add or subtract any of these?
the X's are
No.
different.
So I get over that. I can't put any of them together. I can't make this easier, right? What can come out of all three?
Y to the fourth.
Okay, at least that.
White 4.
At least that. How many x's do they all have?
White.
5.
That's the most.
The lowest exponent I see is a 5. So, again, the students who do really well at math are the ones who are able to break a problem into its parts. That first step was not hard. Because what's the cool thing about them? The numbers definitely have nothing in common, right? 31's freaking prime.
Yeah.
Ain't nothing coming out of him. What's the shortcut on the variables? The smallest exponent. So I can take 5 x's out, and all the 4's are tied. So I can take all 4 y's out. That first step is easy. You always try GCF first, always. What's left now?
14 X
X
squared
And all the 4 y's are gone.
minus 31 X
Good. Had 6, took 5, took all his y's.
plus 6.
I like it. Had 5 and 4, took 5 and 4. Now, do you guys see how that is now in the right format? Do you see how the middle one is always got to have half the first dude's power? Because what's the first step we do? Isn't this going to be something x, something x? So the middle term's going to be something x. I mean, you guys kind of see what I'm saying?
Yeah.
So I can only go further if this is a 2, this better be a 1.
Right.
So the first thing we do is cut this guy in half. Okay. So what method do I use here? What's the first step?
Then you bring it down again.
Yeah, this is not a 1. So I'm going to do 14 times 6.
84.
Cool. Notice something too. This is a relatively large number, right? So I'll bet you it's got to be something small and something big. So 84 divided by 2 is what?
42.
42. That's not going to make 31 though, right?
No.
84 divided by 3.
3,
28. What's 3 plus 28? 31. Do you see what I'm saying? If the middle one was tiny, that would mean that those have to be really close to each other. I wouldn't want to divide by a small number and have a big number left over. That's big. Try to divide 84 by small numbers. Break it up that way first, right? So 3 and 28 work as long as they're both negative. So what do I use these to do now?
To break down the 31. Negative 31.
I like it. So remember, this guy comes for the ride. Don't leave him behind. This guy's still here. I can write this now. They're both negative, so oh well, too bad for me.
Negative 3s minus 2x plus 6 group.
You guys see that?
Yep.
So this is still here. It's still the same thing. I haven't really changed it, but now I have made 4 terms. What comes out of these two? X, good. I'm left with, yeah, it's the only thing, right?
14x minus 3.
I like it. 14x minus 3. What comes out of those two?
2.
2, what kind of 2?
Negative.
Negative 2, right? So that's going to change sign and become positive,
14x minus
and that's going to
3.
change sign and become negative. Blush.
Excuse me.
And you see how you're on the right track. Why am I on the right track?
Because they match, the Huya thingies match.
These dudes match.
Huya.
With huyas. So highly technical term. So yeah. Right? If they weren't the same, I know I'm on the wrong track. Something went wrong up here. So now that those are the same, this guy comes for the ride. What can come out?
The 14x minus
And what am I left with?
x. I like it.
Now, you know, it's really easy as a student to get lost, especially when you get done with a problem and then you kind of look up and you're like, holy shit. But every little step we did was not that terrible. That's the important thing. Somebody who does really well in math is able, either instinctively or they teach themselves how to break it down into its little parts. Taking this out was not hard. Remembering to multiply these, not that bad. Just if it's not a 1, you got to multiply those. Finding these factors, that sometimes takes a little while, but it's not hard. You just start dividing it by numbers and see what works right. Yeah. You're good? All right. All right. So here we go. Last thing I think here.
On that last project, I did that last 2 steps.
Oh, from starting from here to here?
Yeah.
So here, so you're cool with us doing this?
Yeah.
All right, and now I've got 1, 2, 3, 4 terms, right? So now you can group. Oh. Here. Everybody else is left. Everybody's missed out on that. You gotta leave early. I got practice tests up here. You probably want one. When is the test?
Monday.
14, which is a week from today.
Do we not have school, right?
So whatever we get through today is what's going to be on the test.
Should leave right now.
Huh?
Should leave right now.
No, then I'll just keep talking to an empty room, and then it'll be officially on the test. I will be that. So let me see, where was I? So you're cool with doing that, and then you group. So only an x comes out of here, and then a negative 2 comes out of these two, right? I know I got to take a negative out because it's a minus right there. These two are the same, they come out, and I'm left with x minus 2. And he just came for the ride the whole way down. It looks like a lot, because you got a lot to keep track of here, but you want to break it down into its parts. Yeah.
You know the last one, x minus 1? That one happened, aren't you supposed to put the y right there too? Or
Which one?
because you're supposed to do the leftovers, right?
Yes, cool. This is on the very outside.
Uh-huh.
So he just comes for the ride inside here.
Uh-huh.
I'm doing inside the parentheses, right? What comes out? This comes out. What's left? This and this.
Oh, okay.
He's on the
Okay,
outside.
good.
He's been taken out already. He's just coming for the ride.
Okay.
I'm working on what's left here. Right? It's sort of like,
Oh,
again, it's sort of like if I factor 84 and I get 2 times 42, do I have to worry about that 2 anymore, really? I just got to remember him at the end, right? But I just keep working on the part that I'm not done with yet. He just comes with a ride. Same thing here. Do I have to worry about him anymore? No, I just got to keep him coming. But I'm worried about what's left here that I got to factor still.
Where'd the negative 2 go then?
There.
Right there.
If you take out a 14x minus 3, you're left with x minus 2.
Oh yeah.
Cool. Okay. Let's see. Sorry, let me check to see how far I went with this. Section 6.3 through 80, okay. Let's try one more here, then we'll get to the next section. Oops. It's a plus 17 there. So what's your very first step? And why do you do that? What do you always check first?
Greatest common factor.
So you can
Beautiful.
take anything.
And can anything come out of all three? No, that sucks. But, oh well. Let's see if I remember how to tie shoes. Yeah, you check. Alright, so nothing comes out of all three because the stupid 17 is prime. So you ain't playing along with this. So like you said, the first step is definitely going to be 24 times negative 20, which is negative 480. And I can't blame you too much if that's where some of you guys kind of stop, but you just start attacking this dude. Now again, this is why I personally like, you never get shown this, but I desperately hope some of you guys understand this. They have to be different signs, right? One of them's got to be negative, one of them's got to be plus. So let me make two things that are 17 apart. Because if they're different signs, they're going to subtract, aren't they? So for example, 8 and 25. Aren't they 17 apart? If the 8's negative, they make 17. But what do they multiply to be? 200. So we did this kind of thing earlier, didn't we? Then it's easy. Now watch what I can do. That's too small, right? It's negative 200. It's too small. So maybe take this up by 4. Yeah, you can do a job. And take this up by 4. Aren't they still 17 apart? Isn't that still 17 there? But what's negative 12 times 29?
Negative 348.
Negative 3?
48.
48? Okay. I'm getting closer, aren't I? I don't know. Negative 15 and 32? Yeah, that's it. Negative 48. I want you to notice something. I didn't know, did I? I didn't know. I had no idea what the hell the right answer was. I sort of hate it when teachers come in with all this pre-done stuff. As a student, it doesn't help you. You're like, you don't see the thought process that goes in. That's exactly what I have to do when I do this kind of problem. I go do this, right? Yep.
My problem is here. How do we start with numbering? We just
I
any
pick
number?
something.
Anything?
Any damn thing.
I started with 48.
What if I
All right, cool. Again, you could do the factors of this and then check to see if they add, or you could do two things that add to be this and check to see if they multiply. Who cares? All I want is two numbers that do both. Who cares which one they do first? So I made them make 17. That makes 17, right? I don't care what you use. You could use negative 10 and
So we have to pick numbers even here that makes 17.
exactly. So wouldn't negative 10 and 27, doesn't that make 17? They're 17 apart, but they multiply to be 270, negative. Too small. Make them bigger, right? I like that. I like this process because it's it's easier to make two numbers add to be something than it is to make them multiply to be something. It's a lot easier.
We've got x to the 7.
All right, now we've got these two numbers. What do I do with those two numbers? Rewrite the middle term. So I got 24x to the 4th minus
15x.
15x to the square.
good 15x squared plus
32x squared.
32x squared
Why are they squared?
because it's squared.
Okay, and you're adding.
See, the problem tells you.
That's what I got.
Yeah,
Adding,
good.
Not multiplying. You're adding.
All we're doing here really is finding the coefficients.
Right.
This sets up what the hell the coefficients of. They got to be x squares there. Otherwise, how are they going to make 17x squares?
Right.
They got to be x squares. Minus.
Oh, darn.
20.
Exactly. We did that earlier. Whatever's in the middle. If it was xy, I would put xy, xy. It's kind of nice. Right? It's not up to you. It's determined already. It's like, thank God. So now what can I do?
3x squared.
It's grouping now because there's 4 terms.
3x squared.
Good. 3 comes out and x squared.
X squared minus 5.
Good. Plus. Here's a cool thing, watch. I feel pretty good about this, right? So how do you make an 8? What do you have to take out to make this 8? Because I know it's got to be the same. What do I take out of 32 to make it 8? 4. So there you go. I take a 4 out. The problem is telling you what you have to end up with over there. Make it happen. If you're like, oh, it comes out. No, 4 comes out to make it an 8. So if you take a 4 out, I get, not surprisingly, 8x squared. Minus 5. Sweet. I mean, this is kind of nice. The problem tells you what to do. That's awesome.
Took out the 3x squared.
Because that's what goes into 15.
Because that's 3 comes out of those 2. And 2 x's come out because it's the lowest. Oh.
Grouping. Yeah.
Grouping, yeah. Once you got 4 terms, I group. Because that's what's there. See, this is here. This is here. And I rewrote this like that to make it 4 terms. What's the last step?
8x squared minus 5 times 3x squared.
I want to record that.
You sound so
I did. Something. I understand. I understand.
But at least the steps are not hard. It's not complicated. It's just figuring it out.
But the problem is a lot of you guys, and I can't, and again, it's really easy to get just, look at this mess.
Yeah.
One thing is just my terrible writing, but another thing, I mean, there are a decent amount of steps. You're not used to something having necessarily this many steps, even though in my brain I'm laughing right now because this is nothing, but this is a lot more than you're used to. You're not used to something taking this many steps. And so many like little side steps and stuff, right?
Yeah.
So it's really easy to get lost in the middle of this problem and go, shit, especially if you're messy like me and you can't keep track of things very well. This is not going to be easy for you. So I'm not trying to say it's going to be easy. I just desperately want the process we go through to make sense. If you try to attack it, and I can see you're attacking it in the right way, using the right process, and you don't quite get the right answer, you don't quite finish it, you'll get more points than if you just kind of leave it blank. Don't even try, right? Okay, so last thing today, and then we'll head out. And compared to what we just did, this should be really, really nice. So, recall. All right, this is not quite 6-4 yet, but I just want to show you an example. X and X.
My X 5, 5.
5 and 5.
Negative.
Negative, negative, right? Because negative 5 makes negative 10. So, now, I'm going to have something with 2 terms. So what have you done so far? You do GCF always. If it's 4 terms, you group. If it's 3 terms, and it's a 1 out front, easy. If it's not a 1 out front, surefire method, or master product, whatever other method you use. So the only thing we're left with that we haven't done yet, we've done 4 terms, 3 terms, now we're going to do 2 terms. So here's an example of a 2-term problem. Let's attack it the same way we did this one. If we attack it the same way we did this one, what's the middle term? It doesn't have one, so what must it be? 0. So I need 2 numbers that multiply with negative 25 and add to be 0. So they have to be inverses of each other, right?
Right.
Right, 5 and negative 5. Does that make sense? So if I have 2 terms, somehow I'm missing middle terms. I need them to cancel somehow, right? So I need them to be exactly the same stuff. Just one is a negative and the other is a plus. Now I got Paul Abdul in my brain. Opposites attract. No. Yeah, I dated myself there. So here's another example of this kind of problem. Wow, it wasn't a joke. It
Negative
really
8,
did
positive
happen.
8.
Yeah. So it's got to be. So notice what you're doing. X squared is x times x. 64 is 8 times 8. What's got to go there to make it work? Minus plus or plus minus. I don't care which way you do it.
That's it.
What if it's like,
So if I had a problem, I think Nicole's trying to say, well, Jeff, what if you had a problem like this?
Good one. Harder.
Then what do you do there?
More challenge, man. More.
It's prime. I can't factor. At least not using whole numbers, and we're trying to, or integers. We're trying to use integers here. I could factor that if we used radicals, but let's not do that. So for us, this is not a square. Doesn't have to be a square for this to work.
yeah.
So that's why we call this a difference of squares. Because there's a minus in the middle of square things, right? That's why we call it a difference of squares. So this is prime because 11 is not square.
So you just say prime.
You say prime.
What if you say no solution?
No, we're not solving anything. What kind of number can you not factor? A prime number. So that's what this is, a number. I just don't know what x is, but it's a number, and I can't factor it, so it must be prime.
So if we say no solution, it's
Yeah, it's kind of wrong. Because I'm not solving anything. It's not an equation.
You just put prime?
Just put prime. Even not factorable. I'll take not factorable. Because it's not factorable. What about this here? How many terms are there? So it's not grouping, it's not trial and error, it's not surefire. It can only be squares or what we're going to learn in a minute, cubes. And it can't even be cubes because I haven't talked about it yet. It's not cubes because they got squares on them, right?
Mm-hmm.
Is everything something squared?
Yes.
Yeah, the 4 is 2 squared, the y is y squared, 25 is 5 squared. Everything's squared. So here's a really cool thing about this. The minute you know it's squares, you cut everything in half and put plus or minus. 4y squared would be what and what?
2y,
2y, 2y.
5.
Plus minus. 25w is 5w, 5w. You're done. Difference of squares is what I call a thank God problem. Stupid easy. I don't care how big I make it, but you know I'm going to right now. It's easy. Can everything in here, let me say it a different way now. Can everything in here be cut in half?
No, not that.
What do you mean? All right,
Yes.
when I say cut in half, I mean multiplicatively.
Yes.
Yeah.
81 is what times what?
9.
So I can cut it in half multiplicatively, right? Because like up here, 25, I can cut it in half. 5 and 5 make 25 when I multiply. So if you could do that, there's two terms. It's got to be squares or cubes. I know it's squares because 25 is 5 squared.
No.
So you start cutting everything in half. 25 would be 5, 5. X4 would be
X squared.
x squared.
Y.
Y10 would be
Y5,
Y5, Y5. You guys see that? Minus plus.
9,
81 is 9 to 9. Should I didn't give myself a number?
5.
A to the
A5,
5,
B to 10.
B10. Did you guys see that? All I did was cut everything in half. Why does that make sense? Because what's B10 times B10? B freaking 20, right? What about the middle term? Minus 45ABX crap plus 45ABX crap. I've designed it so the middle term goes away, right? This and this is the same as this and this. It's just different signs. Middle term goes away. Don't even have to worry about it. Middle term
That's
goes
the answer?
away. You guys with me on that?
Yeah.
Why does the middle term go away? Like up here, it's a little easier to see. 10wy's minus 10wy's. If I put the same numbers, just different signs, won't the middle terms always be the same, just different signs?
Yeah.
So they'll always cancel. What about this here? Sort of, but not really. I haven't talked about cubes yet. That would be evil, so I must not mean that. What do you always do first? I don't care what the hell's going on. GCF. GCF will save your ass. Right? Always try GCF first.
6y.
What comes out of both?
Or 8y.
2y.
4y squared
4y squared.
minus 9.
And what's this? 2 terms. And are they, everything can be cut in half? Yes. So the 2y comes to the right. 4y squared is 2y. Minus plus. 9 is 3, 3. Difference of squares equals, thank God, Prof. All you do is cut them in half and put plus and minus. They are beautiful.
Difference of squares got a minus sign in the middle, and they got to be also.
So the last thing today, then we're out. So this is the last part of section 6.4. And then 6.5 will be on the next test. I think so. And this is the one that students normally really hate. Because all the other ones we've done so far, you can kind of work at, right? You can make the numbers work, you can cut things in half. This is the one you have to memorize the form of it. So I'm going to really try hard to make it make sense. Yes?
Why didn't we do GCF with the first
Well, I should be saying, and it's my fault, because I should, every time I should say, can anything come out of both of these? Of course, me, I'm making it so it doesn't happen, so I just forget to say. You always say, does anything come out of here? No. Does anything come out of both of these? No. Right?
Just because there's
So we should be doing GCF first thing every time.
whenever there's something to
Whenever. If I say factor, the first thing you try is GCF. I'm not saying it's always going to work. It didn't work here. There's no GCF. So I just go, oh, no GCF. Let me count the terms. 2 terms. Oh, it could be squares or cubes.
we'll have to look for the GCF first and then
Because here, we couldn't do anything unless I took that out of the way first, right? So GCF makes it possible to be done. Cool. So if this, how does that factor? I like it. Minus plus, I like it. Or plus minus, I'm not. Right? X squared in half is x and x. 4 is 2 and 2, minus plus. Because there's 2 x's, so one goes there and one goes there, right? And 4 is 2 times 2, there's 2 2's, so one goes there and one goes there. So what should happen then with cubes? How much of each thing do I have?
3, 3.
X cubed is x times x times x. 8 is 8. Calm down. 2 times 2 times 2. Now here's a part you just...
You make 3 of them.
No, it doesn't quite work that way, unfortunately. You would hope it would, but if I had 3 little dudes, don't I have to multiply the first 2 and then multiply the last one? Is almost impossible to get everything to cancel that I want to cancel. There's too much stuff going on, right? No, just go with me. Can you guys give me a little faith? It's just a couple of them and we'll get the process down.
Sure.
I always tell people when there's cubes, there's a little dude
And a big dude.
and a big dude. Right? There is. Alright, now stay with me now. There's 3 of everything, right? So I can put 1 of each in one of them and 2 of each in the other one. Just like here, there were 2 of everything. So I put 1 there, 1 there, 1 there, 1 there. That's easy. 3 of each, shit. 1, 1, 2, 2. So overall I get 3. So here, watch this. This is a method I've developed over the years. Stealing some stuff from students' work and stuff. Because some people do neat stuff. So this I stole from a student a while back. Breaking it down like this, because watch what you can do. The little dude is a little dude. Little tiny dude. So you can only take 1 of each. 1x minus 1, 2. So how many x's should go there to complete x squared, right? And at the end here,
4.
so far, now, right, everything I've done so far, doesn't that make some sense?
Yes.
1 of each, 2 of each. I get 3. Ooh, right? That's like, wow, Jeff. Here's the weird part. And it looks like I don't need to do anything else. There's my x cubed, right? There's my minus 8. Yay! Do I want anything else? Oh, but shit, I got minus 2x squared. Shit. And also I get plus 4x, don't I? Do I want those?
No.
They can't be there because that's not part of the answer. It's not part of the problem, what I started with.
Minus 4.
Here's the funny thing. I can't just directly kill these because I'm multiplying stuff. The answer is, in the middle goes the cancellation term. It's going to be the opposite sign. Why does that make sense? It's a cancellation term. It's got to be the opposite sign. So plus this times this always. Whatever the hell's in the little dude, this times this, 2x. Watch what that does for me. And then I'll do it again. And I know right now you're going, oh shit, but it really wasn't that hard until we got to the middle term. But the nice thing is the middle term is always the same. Opposite sign, these two multiply. Always. So watch what it does for me. I had a minus 2x squared, didn't I?
Yeah.
What do I get here? X times 2x plus 2x squared. Gone. And I got a plus 4x. Minus 2 times 2x minus 4. Gone. So that's why it's called a cancellation term, because it cancels the extra shit you don't want.
Wait, so it's
Always.
2x?
If it's a cube that's factorable, this will work. I'm sorry, Nicole.
It's always 2x?
It's always this times this. So give me two. I'll do two more up on the board, and then we're out.
So what is?
I gotta give you your practice test though, so don't get out that
Is
door.
the answer that middle part?
The answer is this. This was me explaining why I needed that. Let's do a couple more. Here we go. So there's two terms. It can only be cubes or squares. No GCF here, right? And it's got to be a cube because it's a freaking cube. It's kind of a giveaway here, right? So then m cubed is m. And 27 is 3, 3, 3. Cool? And then what do you slap down it because it's a cube?
M plus
Little dude?
Little dude, big dude.
Say it and make me happy. Big dude.
M minus 3.
Good. One of each. M plus.
Oh.
So that was a minus because that was a minus. Right? M plus 3. So what's got to go here? The other two m squares, so I get my m cubed. We've got at the end, it's got to go 9. Multiplying there, right? So then I get my 27, see? Good. The middle term's got to be minus 3m. Is that hard? No.
It's got to be the opposite sign.
What I would do if I were you, we'll do one more. If I'm you, obviously I'm going to do my homework, but like half an hour before the test, I'm going to do several of those because it's all about the process. So you just need that in your head. What goes where, when, you know. Let's do one more. Let's see. That was hard. Save the best for last. Now remember, with squares, we cut everything in half. Cubes, I got to cut everything in thirds, right? So 8y6 would be 2y squared, 2y squared, 2y squared. You guys with me? 8 is 2 times 2 times 2. Y6, cut in thirds. Y2, y2, y2. Does that make 6 y's? Exactly.
5x, 5x, 5x.
Yeah, now this one, 125, some of you guys might know this, but a good guess would be 5. Sure enough, 5 times 5 times 5 is 125, and each one gets an x. 5x, 5x, 5x. So now, little dude, big dude, and now it's a little big dude and a big ass dude here, right? Too much stuff going on. What goes in a little dude? Little dude's a little tiny dude. One of each. So 2y squared
5x.
minus
5x.
5x. So those have to go here. 4y to the 4. How do I know I'm on the right track so far? What power do I get here? 6. So I know I'm on the right track here, right?
Yes.
What goes at the end? 25x squared. So again, I know I'm on the right track. I get my x cubed and I get my 125. Plus
10xy squared.
10xy squared. You guys see that? And you just throw those together. 5 times 2 is 10. xy squared.
Wait, did that say 4y?
Alright, where'd you get the 10Y square from?
Where are we at? Here?
Yeah.
The middle term is always, this times this. Always.
Always.
Opposite side, this times this. Let me give you guys a practice test. The answer key for you next time.
We don't turn that in today?
No. This next test will count for your first test.
Whatever is in the first one, which is negative
No.
5.
I'm sorry.
Oh. It's always positive at the end. The last one's always positive. Always. Yeah.